What up, my road dogs? We're going directly into 5.5 after 5.4 because they're super similar to each other. It's really similar to just solving regular equations. Um, oh gosh, I need to adjust that. That should say multiplication or division. My bad. That's a typo. I will have that adjusted um, for the printout. Sorry about that, guys. Whew, gosh. All right. Alex and Hope are trying to solve negative 6x is greater than 24. Whose inequality shows the solution? We got Alex's work showing that you have to choose a number that's greater than negative 4, and then Hope's work showing that you have to choose a number that's less than negative 4. So before we actually get started, let's actually pick a number that's greater than negative 4 for Alex. Let me do this in a more similar color for Alex. Uh, Greater than negative 4, right? It's going to be like negative 3, for instance. But if we take a look at Hope's work and we say, actually, I don't have a green with me, a number that's less than negative 4, we'll just choose a negative 5. Okay. And technically, it's every number that's less than this, right? But this is just one example of a possible answer. Okay. So we'll go back to that original equation that negative 6x is greater than, my bad, dang dog, is greater than 24. Okay. Now I've got this negative 6 x, that's multiplication. So the inverse or the opposite is division. So we get our x right here, and then 24 divided by negative 6 is a negative 4, right? Which, I mean, Alex and Hope both know that. So they have some decent level of understanding of how to solve these things. But the question is what inequality goes right here? You might be tempted to think that it is a greater than symbol because that was in the original equation. But that's where the kind of like small difference comes in, because this is very similar to how you solve an equation and other inequalities with just one small difference. Okay. And then let's talk about that difference right now. So if I take a look at Alex's work, right, and I get the original equation right here, that negative 6, and I'm going to plug in Alex, like something that's greater than negative 4. So we'll take that negative 3 and plug it in, and we'll use the original equation. Actually, stick to my colors here, right? So this is Alex's hypothesis right here, right? Alex says that negative 6 times negative 3 will give me a number that's bigger than 24. But we multiply this out. I get negative 6 times negative 3 gives me a positive 18, which is not greater than 24. Okay. So then we'll take a look at Hope's work. And all we have Hope's work, what she did is she just took this inequality sign and just flipped it around. Okay. So we're going to do that and plug it in, right? So let's see, what color do they use for Hope? I use gold. So Hope's down here. We got negative 6. And then we're going to plug that, let's see, negative 5 in here, right? Okay. And then we go back to that original. We got this. This is good. We're just plugging back to the original equation, right? So negative 6 times negative 5 is a positive 30, which is greater than 24. So it looks like Hope's work is correct. And all she did was flip the inequality around. So whenever you are multiplying or dividing by a negative and you're using inequalities, you take the original inequality and you just flip it around, right? So this greater than becomes a less than in the answer. So Hope's work is correct. Okay. That's it. That's the one difference. Okay. So hopefully you can remember that. All right. Gina's pot-bellied pig, no, is on a diet. You can have no more than 18 ounces of pig food per day. How many scoops of pig food can Gina feed the pig without going over 18 ounces? Write and solve an inequality, and then graph the solution. I love the cerdo vergon. I don't know if that's correct or not. That was just what Google Translate told me. So we've got 4 ounces per scoop based on just the picture right here. And in the book, it said to use S as your number of scoops, like how you define your variable. But I hate using S as a variable because my S's look like 5s and it confuses people. So I pretty much always just use X. So I've got 4X is less than or equal to the maximum daily ounces, which is, I think, 18. Okay, so that's our inequality right there. Now we'll solve it, kind of like tighten it up a little bit there. I got 4, I divide by 4 on both sides. I get X is less than or equal to. And I'm not flipping the inequality around for this one because it's a positive number. So I don't even have to worry about that. So I take 18 divided by 4 gets me to 4.5. So X is less than or equal to 4.5 scoops, right? So basically, each scoop has to be less than 4.5. Well, no, sorry. What am I getting at here? There are a maximum of 4.5 scoops in that bag based on how much she can feed that pig. So let's graph it here. I got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is going to be between 4 and 5 because it's 4.5. So like kind of like right there. And since it's got this or equal to on it, it's going to be a closed circle. And so the inequality is telling me to go left. So I draw my arrow left. Ta-da. Okay. Solve the following inequality and then graph the solution. So we've got division right here. So I'm going to do the opposite, which is multiply. So I got 7 times 15. 7 times 15 gives me a 105. So D is greater than 105. So I just go 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, and then 110. And then I'm going to start at 105. Now, there is no greater than or equal to, like on this one, which gives you a closed circle. So I'm just going to do an open circle. And then the arrow is telling me to go that way, or the inequality is telling me to go that way. So that's where I draw my arrow. Okay. Okay, now this is when we kind of like practice dividing, multiplying by a negative value, right? And so you just got to remember that you flip the inequality when you're dividing by multiplying or dividing by a negative, right? So this less than or equal to flips around to a greater than or equal to, and then we just take that 17 and we divide by negative 3.4, and we end up with, oh gosh, you can't even see that. I'm sorry, guys. So let me flip this a little bit so it's easier to see. Okay, so we take that 17, we divide by negative 3.4, we get to negative 5. Okay. So then I'll start at negative 10 on my number line, negative 11, negative 9, because it's going up, right? Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and then 0. So it's greater than or equal to, so it's going to be a closed circle, okay? And going to the right because my inequality is pointing that way, okay? Same thing, right? Except this is division, so the opposite of division is multiplication. So I multiply by negative 2.25 on both sides. Again, we'll just use the calculator for this. I take 7 times negative 2.25 gets me to negative 15.75. And don't forget to flip your inequality. So it's less than or equal to negative 15.75. Okay. Let's start at negative 20. -15, -14, -13, -12, -11, -10. So actually, it's probably a little bit more like there. And it's a closed circle because it's got the or equal to on it. And it's telling me to draw my arrow to the left. So that's what I do. There you go. Okay, there you go, guys. Enjoy.